Hello students. So today's class we are going to see the numerical problems of 12th standard physics unit 2 current electricity 9th sum. So they have given a circuit diagram like this and here they have asked us to find the values of currents I1, I2 and I3. Okay, first try to understand the diagram. So here we have 6 different junctions A, B, C, D, E and F. And then here we have a 15 voltage battery is being connected. Here a 9 voltage battery, and then this is the direction of current I1 and this is the direction of current I2, and in between the junctions B and E we have a resistance of 100 ohms, and between the junctions E and F we have the resistance of 100 ohms, and between the junction C and D we have the resistance of 100 ohms. And here also there is a battery of 9 voltage with a positive and negative terminals. Okay, first we are taking the junction, that is at junction B. Okay, at the junction B we are applying Kirchhoff's current rule. Okay, Kirchhoff's current rule. So towards the junction B we have to see. So I1 is towards the junction B. So I1, I3 is away from B, and same way if you see I2, that is also away from B. So whichever is away we will have to take minus sign for that. So minus I2 minus I3 equal to 0. Therefore I1 equal to I2 plus I3. This is considered as equation number 1. Next, taking the junction, that is actually it is a loop. At the loop A, B, E, F, A. A, B, E, F, A. We are applying Kirchhoff's second rule, that is voltage rule. Okay. So A, B, E, F, A means everything should point towards A. So whichever is towards A, that one can be considered as positive. So you just see 100 I3. 100 I3. Then next one 100 I1, because I1 is also going like this only. So plus 100 I1 equal to, here you have 15 voltage, so that value itself you can substitute. Okay, so now here this one you can consider as equation 2. Now 1 can be substituted in 2. Substitute 1 in 2. So 100 I3 plus 100, instead of I1 you can substitute I2 plus I3 equal to 15. So which further gives, you can multiply this 100 inside. So we will have 100 I3 plus 100 I2 plus 100 I3 equal to 15. So 100 I3 plus 100 I3 becomes 200 I3 plus 100 I2 equal to 15. So this one you can consider as equation number 3. Okay students, so we got the third equation like this. Now again we are taking the loop. At the loop now B, C, D, E, B. Okay, at the loop B, C, D, E, B, we are applying Kirchhoff's voltage rule. Okay, so everybody, they should, all the currents should point towards B. That one has to be taken as a positive one. Okay, so here you can consider 100 I2 but minus 100 I3 is equal to, if you just see the value of voltage, that is also minus, because this is going this side, opposite direction. It is not pointing towards B, it is away from B. So you can consider that one as minus 9. Is it clear children? Now you can take this one as equation number 4. So now you have to change this minus as a positive sign. So what we can do, this one has to be changed as positive and this one has to be changed as negative. That means 100 I3 minus 100 I2 equal to 9. So let us consider this as equation 4. This is not 4, this is only equation 4. Now you are just adding add equation 3 and 4. Okay. So equation 3 we have got as 200 I3 plus 100 I2 equal to 15. Then fourth equation 100 I3 minus 100 I2 equal to 9. Okay. So now 200 plus 100 we will get 300. So 300 I3, this one get cancelled. Here 15 plus 9 becomes 24. So 300 I3 equal to 24. Therefore I3 is equal to 24 divided by 300. You can cancel using second table. You will get 12 by 150. Again further if you cancel using second table you will get 6 by 75. You cannot cancel this one further. We can divide it here. So 6 divided by 75. Put a 0, 0 point. Again it won't go, it's a small number. Put a 0, then one more 0. 75 you can try with 8 times. 8 5s are 40. 7 8s are 56 plus 4 you will get 60. So 8 times 600. Okay. So you got the value of I3. I3 is equal to 0.08 amperes. Okay students, we have got the value of I3 like this 0.08 ampere. So we already got this equation, isn't it? 100 I3 minus 100 I2 is equal to 9. So in this equation you can substitute the value of I3. So you will have 100 into 0.08 minus 100 into I2 is equal to 9. So 100 into 0.08 becomes 8. So 8 minus 100 into I2 is equal to 9. So minus 100 into I2 is equal to 9 minus 8. So minus of 100 into I2 is equal to 1. Therefore I2 is equal to minus of 1 divided by 100 which is equal to minus of 0.01 ampere. So now we have got the values of both I3 and I2. Do you remember the equation 1 children? That is I1 is equal to I2 plus I3. So here you can substitute both the values of I2 and I3. So I1 is equal to I2 we have got as minus of 0.01 plus 0.08. So the signs are different. You have to subtract and you have to put the sign of the greater one. So normally you will get I1 is equal to 0.07 amperes. So you can write the values like this. Minus of 0.01 ampere and I3 is equal to 0.08 ampere. So these are the values of the currents I1, I2 and I3. Thank you.